So let's look at two more challenging examples for determining whether numbers are rational or irrational. And remember, a rational number, it has the word ratio in it. It can be written as a fraction. In fact, it can be written as a fraction of two integers, two different whole numbers. And irrational has that IR in front, so that negates the number or the word. So that is a non-fractional number, or in other words, it's a number that cannot be written as a fraction. So in the last several videos, we looked at different decimals, and in the intro video, we did look at one example of a square root, but in general, square roots tend to be irrational. But there are certain instances where a square root is a rational number. Specifically, if you have a square root of a number that can be written as a perfect square. So 4 can really be written as 2 squared. And we know the square root of 4, what number multiplied by itself gives you 4, is just 2. So when you can rewrite it as a perfect square, the square and the square root cancel each other out, and you just get back a whole number answer. And remember, whole numbers are fractional numbers because you can divide anything by 1 and it would still be the same number. So certain square roots are rational numbers, but most square roots aren't. So root 2, root 3, root 5, root 6, root 7, root 8, and root 10, and so on. These are all irrational numbers. They cannot be written as fractions. And in fact, if you tried to plug them into the calculator, you're going to get a decimal expansion for these. Now, because the calculator cannot go to infinity, it will have to round at some point. So for instance, when you plug the square root of 3 into your calculator, let me just rewrite that. When you plug that square root into the calculator, you get 1.732050, and it's going to go on forever. But the calculator, depending on how good your calculator is, will round it at some point. So it will look like it is a terminating decimal, and terminating decimals we know are rational, but the calculator, because it can't go to infinity, has to terminate it at some point. So they might look like rational numbers on your calculator, but the key thing to notice is that there is no pattern in these digits. It's not going to be repeating in any place. Since we know if we have a repeating decimal where we have this bar above it, even though that is an infinitely long decimal, that actually is a rational number. And we looked at tricks for how to write that as a fraction. But most of these square roots cannot be written as fractions, except when we have a perfect square underneath the square root. So notice I did not include 9 because the square root of 9 is really just the square root of 3 squared. We were able to write underneath the square root as something squared, so the square root and the square cancel, and you just get back the base of this perfect square, which was 3. And that should make sense because the square root of 9, what number multiplied by itself gives you 9? That is 3. So other examples would be square root of 16. We know that's 4. Root 25. That's 5. Root 36. Root 49. And so on, even maybe like the square root of 100. So there are infinite number of examples of these perfect squares, but they sort of thin out the bigger the numbers get. So in some sense, the irrational numbers in the square roots, they are denser. They're going to show up more often. So we need to be careful when we have square roots. And the main question is, can you write this as a perfect square? Now, 200 is a little bit difficult because it's a bigger number. But remember that 200 is really just 100 multiplied by 2. And 100 is really 10 squared. But we have this 2 to the first power out front, and that's going to create the difficulty. Because if we were to try to simplify this square root, we have 10 squared on the inside times 2. We could separate this into a product of two square roots. This is root 10 squared multiplied by root 2. So if you have a product underneath, you can write it as a product of square roots. And this square root we can actually take. This is just 10. But this, well, we can't take the square root of 2, or we can't write that as some whole number. It would be this infinitely long decimal expansion. It's 1.414 something. Goes on forever. So we generally just leave this as the square root of 2. And this is an irrational number. There's no way to write this as a fraction. So if you cannot find a perfect square underneath the square root, then you know it's irrational. But the second example here, 121 is really just 11 multiplied twice. So that is a perfect square. That's 11 squared. So when we take the square root of 121, we're really just taking the square root of 11 squared. So the square and the square root cancel, and we get 11. And that's a whole number. That can be written as a fraction since we can divide it by 1. So since this is writable as a fraction, we can conclude that that's a rational number. So with square roots, you just need to be careful. If they are perfect squares, then you can write them as rational, or if the number underneath the square root is a perfect square. Now, if the number underneath the square root cannot be written as some whole number squared, like we had here, then it's an irrational number.